Welcome back to Tracing the Sky. So in the last video, we wanted to see if we could figure out how the stars were moving, whether there was a general rule that they were all following. And so to make our lives easier, what we did was we looked at groups of stars because trying to track each individual star would take multiple lifetimes, right? So we looked at groups of stars that we called constellations, and we wanted to see if we could track their movement in order to learn maybe how all of the stars moved. I think we learned some really interesting things. So the first thing we noticed was that the group of stars in the constellation were moving together. No one star was speeding up ahead or lagging behind or zinging off in a different direction. They were all going east to west, and they were following the same arc, and they were all grouped together in the exact same way every time we looked at them. What was also really interesting is that we saw they were moving at a constant speed. So what do we mean by that? Well, we looked at the constellation every 10 minutes, and the distance between the constellation never changed. The distance the constellation traveled over the course of 10 minutes remained the same every time we observed it. And so it was moving at a constant speed over that time. Now, the really interesting thing happened when we looked at all of the constellations as a whole, how the three main constellations we were looking at moved relative to each other. And what we noticed is they all seemed to move as a single unit. The distance between the constellations never changed, and they were all following the same motion. They were all going east to west, and they were all seemed to be on this arc. And what we could kind of conclude from that was that it appeared as if the entire sky was moving the constellations, was dragging these constellations across the sky. And so we started to conclude that, all of these stars are moving as one. They're not moving relative to each other. So perhaps the entire sky is full of these stars that are all moving as a single unit through the sky. And we wanted to look at another question, which was, well, if we go out at night at different times of year, whether it's July, September, January, May, would we see the same thing? Would the sky look the same? If the stars are moving at a constant rate, would they appear the same every single night, day after day, year after year? And so that's what we're going to start to look at today. Okay, so here we are facing north, and I've gone ahead and marked out for us a couple constellations and groups of stars. So we've got the Big Dipper, which isn't a constellation but is part of Ursa Major, and Cepheus, which is a constellation. And so what I want us to do is track these stars every 30 minutes or so and see how they're moving. Now, we've said that there's a general rule, which is that the stars are moving in an arc from east to west. Now, just as a reminder, we're facing north. So east to west is a little bit backwards than what we've been used to, right? It's, this direction. And what we want to see is, how are these stars moving? Are they doing anything different? Are they going east to west or moving in a different way? So if you want, you can do this demo for yourself. I've got a link in the description, and you can try it out, and then meet me back here and we'll do it together. Okay, let's have a look here because there are some really interesting things going on. So, just as a reminder, when we first started our observations, we were looking at Cepheus in green and the Big Dipper in red. And what I did was I jumped us forward an hour at a time, just to make the apparent motion really obvious. And I did that 3 times so that we could see how it moved over the course of several hours. And so everything looks just like we would expect, right? For Cepheus, at least. It's going from east to west, and it looks like it's traveling in an arc. And just a reminder, we're facing north, so east to west is from right to left for us. When we're facing south, east to west is kind of opposite, from left to right. But it gets really interesting when we look at the Big Dipper. Because the Big Dipper, I think you could describe this as an arc, but it's not an arc that's rising in the sky. It's kind of an inverted arc. It's the opposite of what we looked at, and it's moving from west to east. So doesn't that kind of violate our rule of thumb? Well, let's remind ourselves of one really important thing. An arc is part of a circle. We've said that from the very beginning, right? The sun is moving from east to west, but it's traveling in an arc, and it comes back around to where it started. So we could project its path and imagine that it's going in a circle around the Earth. And the same is true for the Big Dipper. If we imagine the path it's traveling, if it's on an arc, it's going to circle around and eventually also be going from east to west, just like Cepheus. And Cepheus would be on the other end, kind of dipping down and going from west to east. But it doesn't contradict that general rule we came up with, because we can think of this entire circle, this arc or circle path that the constellations and stars are going around, as moving from east to west, that the entire circle is moving from east to west. You know, another way we often describe this is it's moving counterclockwise. If you think about a clock and how the hands around a clock move, we talk about circular motion as going clockwise around the clock or counterclockwise. And so that's how we would describe the entire circle. Okay, this is really interesting and a little unusual. And let's start to put some of these puzzle pieces together. So far with some of the constellations we looked at last time and even the sun, the arc and the path they were traveling was very wide, right? They would go all the way from east to west in a single day or night. And so that meant the circle was really, really big. But here we have Cepheus and the Big Dipper, and their circles are smaller. And so they're never going to come out of sight. And we've seen, if we put some of these pieces together, that all of the stars are moving together as one. Each group of stars is moving together, but also relative to each other. You know, they're moving together. And so if they're all moving from east to west in these circles, what it looks a whole lot like is that there are stars moving on varying size circles, right? You could have stars that are kind of out here, stars that are closer, and, you know, circles move around a point. And so it raises an interesting question. If all of these stars are moving together in a circular motion, then the only difference is how close or further away are they from the center? What's at the center? Well, what I would do is pause the video and use that same link I included and, you know, move forward in time and try and make your circles smaller and see if there are any points that aren't moving. See if you can figure out what the center of this giant circle is, of this giant sphere that we're looking at. And see if you can pinpoint any star that isn't moving. And before you click on anything, see if you can figure out what star that might be. Okay, let's do this together. So just for reference, here's the Big Dipper and here's Cepheus up here. And what I want you to do is, I'm going to jump us forward in time, and what you'll do is just keep your eye on stars at the outer edge of this giant circle, and then make the circle smaller and smaller until you can find out what's at the center, right? Try and figure out that point. So let's move us forward a little bit, and as I'm kind of looking out towards the outer edges of this giant circle, I see that stars really far out east are rising and there's stars setting and there's new stars coming up all the time, every 5 minutes. But as I start to narrow my focus, the stars closer towards, you know, the center around the Big Dipper are never going out of sight. They seem to be going around a certain point. And there are these smaller and smaller circles I can make, and eventually my eye lands on one particular star that isn't moving at all, that doesn't seem to be moving. So keep your eye now on this star, and I'll move us forward 5 minutes at a time. And it's really fun to just look at that particular star and notice in your peripheral vision how all the stars are moving around it, but it's not moving. Everything seems to be moving together around this single point. And can you guess what the name of this star is? Okay, well, I bet you guessed which star this is. We are facing north after all, and there's only one really famous star in the north, and that's the North Star. You can see it's directly over our northern point here. But do you know the other name for it? It's actually called Polaris. So Polaris is the North Star, and it's a fixed point that doesn't move. And in fact, it looks like all of the stars are going around Polaris. It's as if Polaris is at the center of this giant circle or sphere that all the stars are studded in, and the entire thing is moving around Polaris. Okay, so we can start to add some color to our description and really round out our understanding of the stars and how they're moving. We've seen that they move from east to west, that they travel in these arcs, and that those arcs ultimately make circles. And as you get closer to Polaris, you can see the entirety of the circle that star is going to travel. We saw that with, groups of stars like the Big Dipper. And we know that they're moving at a constant speed and that the distance between the stars isn't changing and they all appear to be moving as one. And that all of these stars together are all going around Polaris. But it still leaves us with that other really important question, which is, if you go out at night in January or September or May, will you see the exact same sky? Will the stars be in the exact same position that they were the previous night or on any given month? Okay, so how can we figure this out, and how can we put ourselves back in the shoes of these ancient astronomers and approach it the way they may have? Remember, they didn't have any fancy technology. They didn't have clocks and digital watches to go out and use to make these sorts of observations. So how can we figure it out in a way that they would have? Well, let's use what we know about the Big Dipper. The circle it travels around Polaris is small enough that it never goes out of sight, right? It's never going to dip below the horizon. So on any given night, we could go outside and look up at the sky and find the Big Dipper. And so how might we kind of tell time or compare it night after night? Well, one thing we can do is use sunset, right? Go out at night, and if we don't have a watch, there's no real way for us to tell time. And so we can go out at night, and as soon as the stars are visible, right, we could go out right after sunset and wait and figure out where the Big Dipper is as soon as it gets dark enough to see. And then we can do that night after night, different times of year, and see where the Big Dipper is at. And let's do that. Let's mark where the Big Dipper is right after sunset, on August 15th, and then see where the Big Dipper is at some other point in time. So here we are right before sunset. You can see we've got the sun just about to set over here in the western horizon. Now, what's kind of tricky is, how do we know if we're measuring the exact right moment if we don't have a clock, right? We're kind of going by feel, by base of when we can see the Big Dipper in the sky, but what if we did this measurement night after night and we're not super accurate? Well, here's something we can do to help figure out how much accuracy we need. Because what we're trying to figure out is the Big Dipper in the same position night after night, or does it change? And so one thing we could do is look at where the Big Dipper is right as soon as we can after the sun sets, make a note of where it is relative to some landmarks, and then maybe come back a few weeks later or months and do the same sort of thing. Right after sunset, see if the Big Dipper's in roughly the same position. If it's pretty close, then we can say maybe our measurements are a little off because of, our accuracy. But if it's really drastically different, then we can more easily conclude that, it's something else is going on here. So let's do that together. Let's jump forward in time 10 minutes at a time. So we'll just, let the sun go forward. And as soon as we can see the stars, we'll make a mark of where the Big Dipper's at. So let's jump forward. And as soon as the sky gets dark enough, we're going to make a note of where the Big Dipper is. So I can just see it now. So there's the Big Dipper in the sky. So let's draw it here. We'll kind of roughly mark its position as best we can. And then what we'll do is we'll choose another day in the year, and we'll do the same sort of observation. We'll look at, as the sky gets darker, where is the position of the Big Dipper the first time we can see it at night, and we'll choose a date that's a few weeks ahead. Okay, so here we are a few months later now. We did our first observations in August, and now we've jumped ahead to November. And we're going to do the same thing we did before. We're going to let the sun set and try and see where the Big Dipper is as soon as it gets dark enough, and then mark its position. So let's do that together. So let's move forward and let the sun set. And the sky's starting to get darker now. And let's see, okay, I can spot the Big Dipper now. So here we are with the Big Dipper, and let's draw it in a different color. And that's pretty remarkable. So over the course of just a few months, the Big Dipper has moved from over here all the way further along its arc down here. So it looks like it's following its arc, but over the course of that period of time, over those few months, where it starts at the beginning of the night, as soon as we can see the sky or the stars in the sky, is it's a lot further along. So that's super interesting. How is that possible? What does that mean? How did the Big Dipper go from being over here at the start of the night to all the way over here? Well, that's what we'll start to dive into in the next video. How we can start to build on this observation, add some more precision, and think about what that even means. So we really covered a lot of ground in today's video. We saw that all of the stars are going around Polaris, and that the stars that are closer to Polaris are on these circles that will make sure that they're visible to us on any night of the year. And we use that to try and figure out if the Big Dipper is in the same position each night or if it moves. And we saw that if we look at it in August versus November, it's in drastically different positions. So next time, we'll really dive into this and figure out what this means and how it's even possible. Now, before you go, if you're enjoying the series so far, it would mean the world to me if you would give this video a like below and subscribe to the channel. That is the best way to help us grow and get this wonderful story out to as many people as possible. I'm really excited to continue this journey with you, and I'll see you next time.